So, today we're looking into the graphing reciprocal function. What does that mean, reciprocal function? If we have, for example, we have function y f of x equal x squared equal x squared minus 2x minus 8. And we need to sketch a graph y equal 1 on f of x. So that is what means reciprocal, 1 over. How we do that? We start from graphing the original function. We start from graphing the original function. So, how we graph the simple quadratic? What we need to do? Factorize. So, what f of x equal, how we factorize it? X minus 4 times x plus 2. So we know x-intercepts, which are 4 and negative 2. What will be the turning point? How we find an x-coordinate of turning point? It is in between, so we have x-intercepts are negative 2 or 4, and x-coordinate of the turning point is always in between them. So negative 2 plus 4 divided by 2 equals 1, or negative b on 2a, which gives us the same result. So x turning point equals 1. What will be y-coordinate of the turning point? Will be 1 minus 2 minus 8. Negative 9. So we can sketch this graph. And y-intercept obviously negative 8. So we have negative 2, we have 4, we have 1, negative 9, we have negative 8. And that is the graph of f of x. Now, we sketch a graph of 1 on f of x. What will happen when f of x equals 0? Can we divide by 0? No. So there will be function undefined. So what we will get there? Vertical asymptote. So graph of the reciprocal function will have two vertical asymptotes. X equals negative 2 and x equals 4. Now, let's consider how the function will behave to the left of negative 2. We have that original function becomes bigger, bigger, and bigger. So what will happen when we divide 1 on it? Yes? Smaller and smaller. So we will have that it will be approaching 0. 1 over very big positive number will be very small positive number. Now, when we have that function approaching original function, so denominator approaching 0, it will be approaching infinity. So that will be this branch. So we get another asymptote. This time we get horizontal asymptote y equals 0. How function will looks like to the right of 4? Pretty much the same. Is approaching 0 when x increasing and approaching infinity when x approaching 4. Now in between, here we are approaching 0 but negative. So we'll have approaching negative infinity. Here, when original function coming to 0 and negative, we'll get very big negative number. And where we have the smallest value of the original, we will have maximum of the reciprocal. What will be the y coordinate of reciprocal? Negative 1 over 9. Because this is 1 over function. Function equal negative 9. 1 over function will be negative 1/9. So it will be 1, 1, negative 1/9. So that will be, yeah, and y-intercept. We need to find also y-intercept. And
One, negative 1.
and y-intercept you substitute instead of x equals 0. Or this was negative 8, will be negative 1/8. Negative 1/8, so that will be our graph of reciprocal function. With the maximum is negative 1/8, maximum at 1 and negative 1/9. Does it make sense how we build this graph? Looking on the graph of the original function, we found that it's reciprocal. And now another type. So that's if we have quadratics in the denominator which is factorable, which we could factorize. Now, what will happen if we have f of x non-factorable quadratics? If f of x, for example, equals, let's say, x squared plus 2x plus 2. And we need to sketch graph 1 on f of x. Can we factorize that quadratics? No, if you look at discriminant, it will be negative. So it's non-factorable. But still, we sketch the graph of that quadratics, which will be parabola completely above x-axis. Y-intercept is 2. What we need to find to sketch this parabola? Turning point. What we're doing to find turning point?
Negative 1.
Completing the square, or we're finding that the x coordinate, x of turning point, equal negative b on 2a, so equal negative 2 on negative 2 equals negative 1. And y, so what will be y? Negative 1, 1 minus 2 plus 2 is 1. So this is negative 1, 1. And that is our parabola. How we sketch now the reciprocal? There is no x-intercept with this one, so there will be no vertical asymptotes. But when this approaching positive infinity, the original function, what reciprocal will approach? 1 over very big number.
Small.
Very small number. So we have here and here. So we have asymptote y equal 0. And what will be the maximum value of the function? Because when we have this smallest, 1 over will be the biggest.
1.
And it will be same for 1 over 1 is 1. So the graph will look like this, and this will be 1/2 y-intercept. So that will be the graph of the reciprocal function. It's never will be negative because original function never negative, it's always positive. So that graph has to be positive, and that's how it will look like.
What, how did you know those are asymptotes? Why did you do that?
Because when we have denominator approaching infinity, positive infinity, 1 over that will be approaching 0. That what is asymptote, the line. But it never will be 0, but it will be infinitely close approaching it. That what asymptote is.
Wait, when will like y be a different asymptote? What's an example?
Hmm?
Like when Is there an example when y, like the y asymptote is like 2?
Put something outside the.
When y will be equals 2, of course it would be.
Like, can you give an example?
1 on
Like
x,
y-
1 on x plus 2.
When
If we have y equal, for f of x equals 1 on x
And then
plus 2. That's hyperbole.
Yeah, well, isn't that just like, yeah.
That's example with the asymptote too. And that's that is what we're learning today. Now we will be practicing more complex functions. We will be learning later on. Like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Iran, Hamas, etc. Support Ukraine and Israel.